Alfred Stock, a German chemist, introduced a nomenclature system to indicate oxidation number for metals that exhibit more than one oxidation number. The nomenclature, known as Stock notation, indicate the oxidation number by placing a Roman numeral within parentheses after the symbol or name of the metal. Thus, the oxidation number of copper, both compound, can be indicated as shown. Based on the name of reaction, redox reactions are divided into four types. These are combination reaction, decomposition reaction, displacement reaction, and disproportionation reaction. Now look at each type of reaction. As the name indicates, a combination reaction is a chemical reaction in which two or more substances combine to form a single new substance. A combination reaction can be represented as A plus B give rise to, or combination reaction to be a redox reaction. Either A or B or both should be elemental state. We know from the oxidation number rule the atom of elements in elemental state have an oxidation number of 0. Thus, when substance with 0 oxidation number combine, one substance will be oxidized and other will be reduced. Let's look at some example of redox combination reaction. Carbon and oxygen in elemental state combine to give carbon dioxide gas. The oxidation number of carbon and oxygen is 0. Carbon dioxide gas is formed. The oxidation number of carbon become +4 and oxidation number of oxygen became -2. Here carbon undergo oxidation and its oxidation number increase from 0 to +4. Simultaneously, oxygen undergo reduction as its oxidation number decrease from 0 to -2. In other example, magnesium react with nitrogen to give magnesium nitrate. In this reaction, the oxidation number of magnesium change to from 0 as it oxidizes. Simultaneously, the oxidation number of nitrogen change from 0 to -3 as it's reduced. Let's look at decomposition reaction. Decomposition means breakdown. Thus, a decomposition reaction is a chemical reaction in which a compound breaks down into two or more substances. It is opposite of combination reaction and can be represented as shown here. Quality composition reaction. To be a redox reaction, it is essential that at least one of the product of the decomposition reaction is in the elemental state. One of the most common example of decomposition reaction is the breakdown of water into hydrogen and oxygen. The breakdown of water molecules into hydrogen and oxygen is a electrolysis process. The oxidation number of hydrogen decrease +1 to 0 as it get reduced, while oxidation number of oxygen increase from -2 to 0 as it get oxidized. Note that as product, hydrogen and oxygen of this reaction are the elemental state. It is a redox decomposition reaction. In this reaction, example of potassium chlorate decomposed to form potassium chloride and oxygen. one of the two product oxygen is present in the elemental state. Hence, this reaction is a redox decomposition reaction. The oxidation number of chlorine decrease from +1 to -1 as it get reduced, while oxidation number of oxygen increase -2 to 0 as it get oxidized. Here, note that there is no change in the oxidation state of potassium. Now consider the decomposition of calcium carbonate. The product we get are calcium oxide and carbon dioxide, as none of the product are one of the elemental state, and as there is no change in oxidation state of any element, this reaction not a redox decomposition reaction. The third category of reaction is the displacement reaction. In a displacement reaction, the atom or ions in a compound is replaced by atom or ion of some other element. This reaction can be represented as X plus YZ convert to XZ plus Y. In this reaction, from the compound YZ has been displaced by X. Displacement reaction are of two types: metal displacement reaction and non-metal displacement reaction. In a metal displacement reaction, the metal in a compound is displaced by some other metal in the elemental state. For example, in this reaction, copper sulfate react with zinc to form copper and zinc sulfate. This is a displacement reaction because copper has been displaced by zinc. The oxidation number of copper has decreased +2 to 0, hence copper is reduced. Simultaneously, the oxidation number of zinc is increased from 0 to +2, hence zinc is oxidized. Thus, reaction is a redox displacement reaction. In this reaction, titanium tetrachloride react with magnesium to form titanium and magnesium chloride. As you can see, magnesium has replaced titanium to form magnesium chloride. The oxidation number of titanium has changed from +4 to 0 and magnesium from 0 to +2. The oxidation state does the reaction is also a redox displacement reaction. Similarly, in this reaction between chromium trioxide and aluminium replaced chromium to form aluminium oxide. In each of the metal displacement reaction, a metal displacement and other and the reducing metal like zinc, magnesium and aluminium are better reducing agent than copper, titanium and chromium that is being reduced. The second type of displacement reaction is the non-metal displacement reaction. In a non-metal displacement reaction or metal or non-metal displaced another non-metal in a compound. In most non-metal reaction, the non-metal displaced is hydrogen. However, some reaction involve displacement of oxygen or halogen. Let's look at example of metal displaced non-metal and all alkali metal and certain alkaline earth metal displace hydrogen from cooled water. For example, sodium and alkali metal displace hydrogen from cooled water to give dihydrogen gas. Similarly, calcium and alkaline earth metal react with cool water to displace hydrogen. Less reactive metal like magnesium and iron react with steam to produce dihydrogen gas. For example, magnesium react with steam to produce magnesium hydroxide and hydrogen gas. Similarly, iron react with steam to produce iron 3 oxide and hydrogen gas. Many metals, including those do not react with cooled water, can displace hydrogen from acid to liberate dihydrogen gas and respective salt. Zinc react with hydrochloric acid to displace hydrogen to form zinc chloride and dihydrogen gas. Similarly, magnesium and iron react with hydrochloric acid and displaced hydrogen from hydrochloric acid to liberate dihydrogen gas along with formation of magnesium chloride and iron chloride respectively. Very less reactive metals like silver and gold do not react with hydrochloric acid, hence cannot be displaced hydrogen. We learn about the activity series of metal and so that zinc release electron to copper and copper release electron to silver. Similarly, halogen also have an activity series. The halogen in 17 group include fluorine, chlorine, bromine, and iodine. These halogens have tendency to accept electron as they need an electron to complete their octet. These tendency cause them to be reduced, hence these are good oxidizing agent. These oxidizing part of these halogen produce as we move down group with fluorine being the highest, iodine being lowest. Fluorine is high reactive and can displace chlorine, bromine and iodine ions in a solution due to its high reactivity. Therefore, displacement reaction of chlorine, bromine and iodine ions with fluorines are not carried out in aqueous solution. Let's look at in this reaction chlorine displaced bromine and iodine ions from the aqueous solution of their salt. These reactions are used to identify bromine and iodine ions. As the bromine and iodine produced have characteristic color, this identification is called layer test. Oxidizing agent that can oxidize chlorine, bromine and iodine ions. No oxidizing agent available to oxidize fluoride ions. This is because fluorine is the strongest oxidizing agent. Is the only way to prepare fluorine is oxidize fluoride ions. Finally, let's look at the last type of reaction, disproportionation reaction, in which the same element is oxidized as well as reduced. For such a reaction to occur, one of the reacting element should exist in at least three oxidation states. For example, decomposition of hydrogen peroxide is disproportionation reaction. Pure oxygen has it gain electron and increase to 0 and decrease to -2 in water, give as disproportionation reaction that illustrated the preparation of household bleaching agent. In this reaction, hypochlorite ions, which show bleaching action, is formed by dissolving chlorine in alkaline chlorine having oxidation state of 0 being reduced to -1 in chlorine ions and being oxidized to +1 in hypochlorite ions. Note that like chlorine and bromine, iodine also undergo disproportionation reaction. However, fluorine with alkali does not show a tendency to undergo disproportionation reaction. This is because fluorine is most electronegative element, hence cannot be exhibit any oxidation state.